Hi guys. So 8-2 is all about mean or median, which would be the best measure of central tendency. Okay, mean and median are measures of central tendency. Okay, let's break that word apart so you can figure out what it means. Measure of central tendency, a measure is a number. Central tendency means what number does the data tend to center around. Okay, if you think about your average in class, you have some grades in the middle, some grades that are high, some grades that are low, and your average is kind of in the middle of all those grades usually, or the median is actually the middle number. Okay, so the center number. So measures of central tendency are the mean and the median. They're somewhere in the middle of your data. The point of calculating a mean or a median is predictions. For example, if you usually get 80s on a test and one time you get a 40, okay, so that's going to drive your average down. But if you wanted to make a good prediction of what you're going to do on the next test, let's say that test you got a 40 on brought your average down to a 72. Next test is coming up. Does that mean that you can expect to get in the 70s on that test? Well, probably not. Okay, you probably will go back to your usual. Everybody has a bad day or a topic that was particularly hard. We would consider that 40 an outlier. Okay, no matter what you see in the shown work and the examples in the homework, we are using our calculator to find the mean and the median. Okay, all right, so the median is going to be best when our data is skewed. Okay, maybe it's skewed because the data has an outlier. Maybe it's skewed because the data is just kind of lopsided. Okay, but either way, if it's skewed, then it would be the median that would be best. Okay, how can you tell if its data is skewed? Again, if you draw that little hill over top of the data, okay, box and whisker is a little bit different. You don't have a hill for a box and whisker. You draw those little hills and you drop a line down through the peak of the hill. All right, you look at the left-hand side, and in a box and whisker you'd go from the end of the whisker to the median. And you'd look at the right-hand side. And one side will be significantly longer. Okay?
Mrs. Higgins, please call the main office. Ms. Higgins, please call the main office.
So we would call this graph left skew because that yellow left-hand side is larger, left skew. We would call this right skew because this side is larger, and this is right skew. Okay, so that's when you'd use the median. The mean is best when your data is symmetrical. Okay, when I draw that hill over top of the graph, it looks more or less even on each side. Don't get out a ruler and measure it or anything, but more or less. Okay, each side looks about the same. And in a box and whisker plot, the distance from the end of the whisker to the median and the end of the whisker to the median is roughly the same. Okay, not exact, but pretty close. All right, you can't always find the mean or the median from one of our three graphs, okay? If you have a dot plot, you can find the mean and the median. If you have a box and whisker plot, you can only find the median. And if you have a histogram, you can't find either one. Okay, so with a mean, you have to have the data or the dot plot in order to find the mean. You can't find it from a box and whisker plot or a histogram. Median, if you have the data, if you have a dot plot, or you have a box and whisker, you can see the median. But you cannot find the median in a histogram. Let's practice this. All right, here's a histogram. First of all, we're going to determine what's better, mean or median. Okay, that data looks pretty symmetrical to me. So your sentence would be something like this. The mean is the best measure of central tendency because the data is symmetrical. And yes, you need to write a little sentence for each one. It's also asking you to find, if possible, the mean and the median. Okay? In a histogram, I cannot find either one. Because I don't have actual data. I can tell how many pieces of data I have. There's 3 values in this bin, 5 values in this bin, 8, 6, 2. But 3, 5, 8, and 6, and 2, they are not the data. Okay? They are how many pieces of data went into that bin. I don't know what the actual data is. I just know there's 24. If I add all that up, I have 24. I have 24 pieces of data. Okay, I know what I'm going to divide by if I have the average to find the average, but I don't have any data to add up. I don't know what it is. Okay, so you cannot determine the average or the mean from a histogram. Median. Well, I can't find the median, but I can kind of ballpark where it's going to be. Okay, so if I have 24 total data points, then the first 3 are here, then there's the next 5, so we're up to 8 data points. In this bin is up to 16 data points. Okay, so we've got up to the 16th data point. So halfway for the median would be between 12 and 13. Okay, so I would know that I can estimate that my median is between 2 and 3 inches of rain. But that's the best I can do. I have no idea what the median is. Can't find it out, don't have any data. All right, a dot plot. Okay, now let's see, let's draw our little hill. Okay, I can see this data is very skew. Okay, skew very much to the right. So the median is the best measure of central tendency because the data is skew. And because this is a dot plot, I have all the data. Each data point is represented by an X. So if I want to figure this out, okay, I go into my L1 and, stat, edit, and if there's 2 X's above the 0, I put 2 zeros in my L1. Then there's 4 X's above the 1, so 1, 2, 3, 4, 4 ones. 3 2's, 1, 2, 3, and so on. So you would put a value into your L1 as many times as there are X's. So I wouldn't put any 7's, I wouldn't put any 8's, 11's, 12's, 13's. Okay, I wouldn't put any of those. But I'd put, 3 of this number, 1 3, 2 4's, 2 5's, 2 6's, 2 9's, a 10, and a 14. I can put all that stuff in. And then I can go to my one variable stats and I can get my at mean, remember mean is the x with a line over it, is 4.25, and my median is 3.5. Okay, which you can't see on the screen right now, but that's what it is. Okay, I'd have to scroll down, below this to see it. And here's what this is going to indicate. If I wanted to predict, there's a new, this is about participants who won gold medals at Special Olympics. I've got an Olympian who is going to come and participate, and I want to give them the most realistic prediction of how many medals they could possibly win. Okay? I am not going to choose the average because there's outliers. This data is skewed. Okay? The median would be a better predictor because 3.5 is about here. Okay? And if you see, that point is roughly kind of in the middle of where the bulk of our data is. All right? So that's a more realistic prediction of, if you're going to medal, how many medals do you think would you predict getting? Okay? It's a better prediction. All right. Volunteer hours at the local animal shelter. So we want to know if this data is skew or symmetric. So we're going to look at each side from the whisker to the median and the whisker to the median. And the orange side looks way bigger to me. So the median is a better predictor or a better MCT. Let's stay consistent here. Better measure of central tendency because the data is skewed right. Okay. All right. Mean. Well, in a box and whisker plot, I don't know how many data points I have. In fact, the only data points I'm even positive about are the 4 and the 26, the lowest value and the highest value. Because the median might not be a data point. It might be 2 data points added up together divided by 2, and the same thing with the quartiles. Quartiles are just a kind of median. So I don't know what any of the data is. In fact, I don't even know how much the data this represents. I don't know how many people they asked, hey, how many volunteer hours do you do at the local animal shelter? So I have no way of determining the mean. However, the median is right here. That's part of making the box and whisker plot. Whoever created this, who had the data and put it into their calculator, that's one of the things that the calculator gave them back out, is the median. Now, it would appear to me that the median is at about 11. I'm going to use this little squiggly symbol. That means about 11. That tells the reader of your work that it could be 10.9, it could be 11.1, but it looks to be about 11. All right, and the point of this is if we have a new volunteer and they want to volunteer at the shelter, they ask, well, how many hours is reasonable to put in? And you can say, well, it's the median is 11. You can kind of give them a ballpark idea of what's a reasonable amount of hours. I mean, some people can do more, some people can do less, but a lot of times people want to know what is reasonable and what do most people do. Okay? Thank you, and see you next time.